Hello, and welcome to the third lecture. So, last time you might recall, I spent pretty much most of the lecture talking about two new computer science concepts, so I sort of introduced two concepts, and those are going to be like the starting point. Today, I'm going to be kind of building on top of those. So, just as a quick review, last time we talked about mostly commenting and the use case for commenting and why it's used and how it's used and debugging tricks you can use with it. And then I also introduced, basically on a more fundamental level, I introduced the idea of printing text to the CLI using the print function in Python. But more generically than that, just the idea of like an output buffer. So basically, how you take information that you have stored in your program and then how to actually push that information to the CLI. The mechanism we use for that in the language we're using, Python, is through that print function. So today I'm going to basically build on top of that. You're going to notice that happening a lot in this class, where basically I introduce a concept and then I build on top of it in the next week and so on and so forth. So sort of a little reminder about how this class works, and just how really, probably most STEM classes work in general, is that most of the information is cumulative. So you're definitely going to want to make sure you're practicing the work that I give you, and also I strongly encourage you to just kind of come up with little programs on your own and use the concepts we've talked about already to sort of help refine it. The assignments I give are really my way of just measuring whether you understand the material. They're not necessarily meant as like a comprehensive, like, oh, I did that assignment and now I'm a master of this. Like they're just my way of gauging your knowledge. But you should always be doing more to help build on the knowledge you already have, and you can do that on your own. Okay, so without further ado, I guess I'm just going to jump into it. So right now you see I have the Canvas page open. I always usually start here. This is just a reminder of the work that you have due for the upcoming week. All of this will be due this following Wednesday. So we're kind of back into the normal phase of things. That first week was weird, where you had only a little bit of time. Now we're kind of rolling with it, and just you get a week every time. Before I jump into actual code, the first concept I really want to talk about today, I want to kind of lay the groundwork for it. So I'm actually going to jump out of Canvas and I'm going to go over to my good friend OneNote. I'm going to just pull that up really quick. Well, actually, maybe before I jump into that, actually, maybe I'll just sort of talk about this high level. So the first concept I really want to talk about is more just kind of separating out two kind of high level ideas, and that's the idea of the kind of memory that computer systems use in general. So I'm going to break it into two categories. One of them I'm just going to refer to as long term memory, and the other one I'm going to refer to as short term memory. Okay. And I just want to make sure that categorically we're all on the same page about the differences and what I mean by short term and long term memory. And I'll give a few examples. So when I talk about long term memory with respect to a computer system, more specifically, I'm referring to basically the hard drive, a hard drive. You can kind of think of long term memory as the memory that you're probably the most familiar with on a computer system. So, pretty much anytime you've ever had to deal with like a file on a computer system, you're dealing with long term memory. You can think of it as a hard drive. In fact, an example of this, I'll just minimize this right now. Here I am on my desktop. Here I have a folder. This folder is associated with a location on my file system on my computer. If I go into the folder, you can go in here, and then let's say you wanted to make a file. Hopefully I'm not blowing anybody's mind right now, but like, you can go to new, I'm going to make let's say a text document, my file or something like that. Okay. And this file is now stored on my file system, so on the hard drive of my local computer. Now, it doesn't really matter whether or not we're talking about something that's on your physical computer. You could be using like a network drive, you could be using a cloud system like OneDrive or Google Drive or whatever the heck Apple uses, I don't even know. It doesn't really matter. All of those are examples of what I'm calling long term memory. And the idea, the main distinguishing characteristic of that is that if I were to turn off the computer, right, and then turn the computer back on, I would still have access to the information I put into these files. Okay, so that's what I mean by long term memory. It means it doesn't go away just because the computer gets turned off. You can kind of think of it similarly to how people think about having long-term memories in your brain, right? Like you might remember that time that you went to the park when you were a little kid with your parents or grandparents, right? You can remember it even though it happened a really long time ago. Versus you might not be able to remember exactly what you had for breakfast, 2 weeks ago, right? Even though that happened much more recently than the childhood memory. It's because some memories are more important to us than others. And so some of the short term memories, those things that you remember just for the brief moment you need to know about it, and then you just sort of forget about it after that because you don't need to keep that information anymore. Well, computers have basically a similar setup. The long term memory is these files. So, file systems are our way of storing information that will be retained long term. You want this information to be saved. This is why you kept a file for it. Okay. I'm going to distinguish that now between the computer's system's version of short-term memory. So when I'm talking about short-term memory, what I'm really talking about with a computer system is random access memory, or RAM. Okay, so if you've ever heard about RAM, most people have heard about it at least once or twice, and usually the way that most people I've noticed know about RAM is that when they're buying a computer, they know they need to have a lot of RAM, and they don't really know why they need a lot of RAM. They just know they need a lot of it. It's better if the computer has a lot of RAM. Well, I'm going to tell you why it's better. Is that means that your computer has a much larger amount of space for short-term memory. So RAM is the kind of memory that computer programs use. So in this class, when we write programs in the class, like 98% of the class is going to be dealing with RAM, okay? The kind of memory that we're actively using, the kind of memory that programmers spend the vast majority of their time interacting with is RAM. Just like how long-term memory, and there's hard drives that can exist on your physical, on-prem, or you can have some in the cloud or whatever. There's lots of different types of like long-term memory. There's lots of different kinds of RAM too. There's like SRAM and DRAM and VRAM and blah blah blah. We're not going down that rabbit hole. That's a lot of extra stuff. I just need you to know that random access memory, or RAM, is short term, meaning that information that you put into RAM only is there while the program is actively executing. After the program has ended and is no longer executing, the information in RAM just goes into the ether. It's gone. Okay? It's short term. It's not meant to be something you stick around for forever. An example of this that you might have is like, well, for example, if I double click on this, it'll open up Notepad for me. And Notepad is a computer program. It's an actual program. And while I have Notepad open and I'm typing and doing all this stuff, here, I'll make this a little bigger just so you all can see it. Will I make it bigger? Where's my... Oh, there it is. All right, so, you know, it's there. I'm writing all my stuff. All the information that I'm doing right now, you know where it is? It's in RAM. How many spaces over I went, where I started here, if I want to, make the font differently, if I want to change, especially if you have a more sophisticated program. If I were using like Microsoft Word or something right now, if I want to bold text, I guess I can do that now in Word, Notepad. Wow. Oh boy, I'm not dealing with that. That was scary. Excuse me. The more you do that stuff, all of those like information that you're doing, even for the formatting, placement, all that stuff, it's all in RAM. It doesn't actually live on your hard drive until you actually try to save the file. So whenever you try to do this and you try to hit save, right? Save as markdown, right? So you can just save as a text file, right? And when you do that, it's actually going to try to put it somewhere on your computer, right? And since I had already opened this file and put it here, this is where it saved that information. So every single time I hit Control S or save, that information that I put in here is going from RAM and is actually being moved from short-term memory into the long-term memory of the computer system, okay? So this is the distinction I'm trying to make. While you're running the program, while all this is happening, while I'm in here and I'm doing whatever I'm doing, right? That's actually the other reason why the VS Code and this text editor has the same little white dot here that let you know when you have unsaved changes. It's letting you know that if you were to close the program right now, right? Like right now, I have things I just put in here that I did not save. If I close the program, right? It's even warning me, hey, you didn't save everything. If I don't save, okay, that means that information was in RAM, the program ended, and it's gone now. And if I reopen this file and I bring it over, that information that didn't get saved isn't there, right? So that's what it means to save. That's the difference between long-term and short-term memory, okay? Basically, when we're talking about long-term hard drive, short-term RAM, okay? And the information that you have access to as a computer programmer, 99% of the time, it's RAM. You're doing stuff in RAM. Okay, I've beaten that horse to death probably. But I wanted you to understand generically what I was talking about. Okay, probably don't need this extra file here. I'm just going to go ahead and delete that. We'll close that guy down. So let's go over to, now we'll go over to OneNote. So OneNote for me is going to be this guy, okay? And I wanted to just kind of talk about RAM high level, but I need you to understand the kind of a little bit of the mechanics of how it works. This is sort of like a fundamental understanding as a computer programmer. So how is RAM sort of organized? Again, I'm not going to get into all the different types of RAM. Generically speaking, all RAM is set up pretty much exactly this way. Now I have these top two rows here, the ones that I have labeled address and value. That's pretty much the entirety of what RAM is made up of. Okay, I have an extra row here for variable just because that's going to be helpful for us later when I start kind of connecting the dots between this and variables. But in reality, RAM is really just those two top rows. RAM is comprised of a whole bunch of address locations, which are just numbers, and values. That's it. That's all it is. It's just a big old table, basically, that's set up just like this. Um, the address locations, ooh, didn't mean to do that. The address locations of RAM are the physical locations, the physical spots on your RAM system, whether that's, again, SRAM or DRAM or wherever. It's the physical spot on that stick that, like, let's say if it's just regular old RAM stick that you would have plugged into the motherboard of your computer, so maybe like SRAM or DRAM, then you would just plug it in, and the stick is like a physical thing. It's like a little stick. It's about this long, right? And you actually plug it into the motherboard, and that RAM stick only can hold so much space, meaning the numbers that are associated with that RAM stick only go up to a certain value, okay? So these numbers, I've put incredibly tiny numbers to what they normally are, but they are very, very big numbers, okay? You're talking like seven or 8 or 9 digits long numbers, okay? They're very big, depending on how much RAM you have. And each chunk of those numbers is associated with a value. So when we talk about RAM, what we're saying is RAM has address space locations, and at specific address locations, you can put information. So every time that you are doing something in your computer program and you need to store some information while the program is running, you're going to use RAM, and you're going to store it at a specific spot, one of these address locations, and you're going to associate a value with those locations. Okay, so that's just how RAM is set up. So I'm going to go ahead and bust out my pen here to draw. Just give me 1 second here. Do a little rearranging. So you can kind of think of this as like here's my RAM stick, and I'm going to go over here, and here's my program. Okay. And my program is a really awesome program. Now you might be thinking to yourself like, okay, so that means that my program at some point while it's running comes over here and looks into the your RAM on your computer and says like, oh, okay, well I'm gonna go ahead and I'm gonna put some information right here. I'm gonna put 21 over here. Okay. Well, I'm going to be honest with you, that is not how the vast majority of programs work, and it certainly isn't how any of the programs are going to work in this class. The vast majority of all computer programs in the world do not directly interact with the RAM associated with the computer system they're running on. They don't. They actually have an intermediary that they go through to get access to RAM. And that intermediary is what we call, if I can get my pen to work again, sorry. We call it the operating system. Okay, and I'll put it in a little cloudy bubble thing here, make it look nice. Okay, and what actually happens when you run a computer program is your program actually makes a request to the operating system, and the operating system says, oh, okay, you want some space to be able to do some work. Cool. I will give you a certain amount of space. Now, the operating system is an important feature. It's actually a very important thing for you to understand that your program has no direct hotline to the RAM on the computer system. Not unless you're doing something on like a proprietary system or an embedded system. Unless you're doing something really specific, 99% of the time, you're running on a computer system that has an OS, an operating system, and when you want to have access to RAM, you're asking the operating system for permission. The operating system is kind of like the parent in the room. You can imagine all the other programs that are running on your system, like these guys. I'm going to say these are all a bunch of little programs, right? And they're all basically requesting space from the operating system. They're all like needy children. They're like, oh, gimme, I need this, I need that, I need this. The operating system is the one who's doling out that RAM to each individual program, right? So you might ask the operating system from my program and say like, I need, let's say, an integer's worth of space. Okay. The operating system is the one who will then look inside of RAM because it's the only thing that actually knows how much RAM it has. It also is the only knows how much RAM it has already given to potentially other programs. Maybe this guy wants a boolean, maybe this guy wants a floating point, maybe this guy wants a string, right? They it's the only thing that knows what space it has given out to the all of the programs. So when you ask the operating system, it's the one in charge. It's the one that goes, okay, for you, my program, I'm going to say that you're going to get address space 256. I'm going to give you address space 256, and you can do whatever you want with it. You can put whatever value you would like inside of that location. That's just for you. But it might decide that this one over here, this guy right here, maybe it needs a float. It says, okay, you get to have this location here at 512. Okay, it's the thing deciding it for you. All right, now I don't want to get too much further into that. I just understanding that relationship between your program, the operating system, and that is how you actually get access to RAM is important. Also to understand that at no point in RAM does it store anything. The only thing it stores is literally one of these two values. It doesn't store the value. It knows the physical location of where things can be stored, and then at those locations it can store a value. So maybe it stores like a 42 here. Okay, so maybe that's for my program. It said here you got 256, you get address location 256, and here's what you're going to store there. You want to store a 42 there? Cool, that's fine. I gave you permission. You can put whatever number you want in there. It has to be a number because you only asked for an integer, right? But that's how it works. Okay, I'm going to swing away from this now. And we're going to head over to, let's go ahead and actually go into here, and I'm going to open up the folder, and we're going to fire up VS Code. And I'm going to move some stuff around here, play a little game on my computer. Always fun. All right, so let's go ahead and create a new project like we have done before. I have my LEC3 folder. Again, I'm going to just open up a new file in here, and I'm going to actually call this one variables. Okay, so that's what we're about to talk about. Variables.py. I'm going to go ahead and just start this off right here. So it gets us to our proper code layout, and now you might notice it has that white dot up there. It means I haven't saved the changes. I'm going to Control S to save. Okay, just trying to reinforce sort of the workflow that you should get into. Okay, so now here we are at the beginning of our program. Let's talk about how we as a programmer represent, like how we access RAM, how we from the text editor interact with RAM. Now, obviously, it would be a real crummy way. It would be really crummy for us if the only way that we could think of storing information was to know all of these incredibly large numbers. Nobody wants to do that. That would be incredibly tedious and frustrating. So, computer systems, all programming languages, basically have this concept known as a variable. And variables allow us to basically create a symbolic a symbol. Okay, we symbolically represent that number, and it's much easier as a programmer for us to think of like these symbols because we can come up with whatever symbol we want, and that the computer program will associate our symbol with the actual location in RAM that symbol like points to. Okay, so when you think about a variable, all you're really thinking about is this is just something I'm making up right now to help me keep track of a specific spot in RAM that my program is going to ask for permission to, right? And this is an important distinction. This is an important concept as a programmer because it allows you to spend your time thinking about the logic you want to implement and not necessarily about the specific computer hardware architecture that you're dealing with, like what kind of RAM, where is it located, how much of it is it. All of this is designed to make it so that you don't actually have to care too much as a programmer about it. But I want you to understand conceptually what's happening because A, it's a computer science class and you should know how to do that. But B, because to be a good programmer, and I'm assuming again all of you are interested in becoming professionals at some point, right? To have that good understanding of the relationship between the software that you're building and how it's actually going to be stored and executed on the hardware is paramount for you to be able to eventually write very efficient and very fast and very like good algorithms that make the most out of the resources you have available, right? But you just have to get that concept down first. Okay, so let's talk about how Python goes about doing this. Now, Python has just like all programming languages, you have the ability to make a variable. So I'm going to demonstrate what a variable looks like in Python. Now I'm going to do it in the most classic Python way first. So let's just start us off with here. Maybe should I make this a little bigger too? Why not? I'm going to just do like, let's say my var, okay? Now, if you just type some random thing in here like this, some characters like this, and then you say equals, and then you actually put a number next to it, let's say, I'll just use a number. We'll say 42, okay? In Python, this is creating a variable. Okay, it's that simple, really. It's so nice if you think about it compared to like all that stuff I had to talk about with like RAM and address locations and values. You need to know that, but like on a practical level, it's not like I'm dealing with any of it right here. I created a variable. That's what I'm calling this right here. This thing that I just made up, right? Then I put an equal sign next to it, and then I put a value here. This value is now going to be stored at this variable location. Now, where this variable actually lives in RAM, I don't have to care. I don't have to know that information as a programmer. All I have to know is that when I run this program, what's going to happen is my program is going to go over to the operating system, say, hey, I need enough space to hold 42. 42 is an integer, right? And so it's going to go, oh, cool. And let's say, in our little fictional scenario, let's say that happened to be address space 256. The 42 would get stored at that location, just like I wrote here. And then for the purposes of our diagram right now, again, I'm going to go back to this. I would say this is where I would write my var. Okay, so I'm just like, this is a chart is my way of like letting you know, like I'm calling address space location 256 my var. That's what I've just chosen to call it, right? But in the end, this is actually a number. That's what ends up happening. It gets mapped to this location because that was the location that was doled out to me by the operating system. All right. I need to get a bigger desk space so I can actually do this easier. Okay. So that is sort of the most classic way you can think of it. And then once you have the information stored there, now I'm going to go back to our good old friend print, right? And I could just say something like the number, or the integer rather, the integer is, and then I'm going to put a comma here. And we talked about this last time when you pass multiple arguments to the print function. What will it do? It will automatically put a space between them, which is why I didn't add a little space after the is here because I know it's going to get automatically appended. And then I'm going to put my var. Now in this case, notice how I didn't actually put a double quote here and here, right? So this is not a string literal. Now I'm actually telling the print function to print my var. Well, because this isn't in double quotes, the interpreter, the Python interpreter, will look at this and go, oh, that's not a string. That's not something that he literally wants me to do it. That must be a symbol of some sort. Has he defined what that symbol is already? Oh, he has. He told me my var is actually 42. So it knows, oh, my var, that's a symbol, and that means I need to go to a specific location in RAM. And it's going to go to that specific location in RAM. It's going to look at the value associated with that particular location in RAM, retrieve it, and then it's going to print that value here next to this string literal. Okay, so that's what's happening. So let's go ahead and just run this really quick. Make sure we all know how that's supposed to work. Python variables, and indeed The integer is 42. Oh no, actually there's one thing I did forget to do here. Let's go ahead and make sure I am using the right version of Python. So again, I'm going to go to pyenv versions. And oh, I'm not. So let's go ahead and pyenv local 3.7.9. And now I'm using the correct version. The other thing I'm going to do is to make sure VS Code does this the right way. I'm going to go over here and click here, pick the right version. Okay, now I'm using the correct version of Python for the IntelliSense. That won't change anything because I haven't done anything that's particularly special for Python. Still says the integer is 42. Okay. Now, that is the most basic way to declare a variable in Python. So I've explained what this does. This is just a symbolic representation of an address location in RAM. Okay. Now I'm going to talk a little bit about one of the operators I use here, this equal sign. Okay. So if you're used to being in a math class, the equal sign has a specific meaning. That sign actually denotes equality. So when you see something like an equal sign in your math class, I guess I'm going to go back to OneNote here really quick. All right. I'll just take a quick little foray into the math world, I guess. I'll scroll down a bit. In your math class, you might see something like somebody goes I don't know, x equals 7 or something, right? Right. Okay, so what they mean by this in a math context is that this value, everything on the left-hand side of this operator, or it's not operator, this symbol, is the same as what's on the right-hand side of that symbol. Okay, that's what it means in math. That is not what it means in computer programming. So the reason I'm drawing this out is because if you looked at math, you might be like, oh, I know what that means. But it's not the same. Computer programming languages don't use this symbol, these two lines, this little equal operator. It's an operator. It's not just an equality symbol. It doesn't mean the same thing. Okay? So what do I mean by that? So if it doesn't mean equality, what does it mean? Well, don't worry, I'm going to tell you. Okay. Let me minimize that. Okay, so in programming, this is an operator, and it is actually what is known as the assignment operator. It's an assignment operator. It has nothing to do with equality, to be perfectly honest. It isn't measuring whether or not two things are the same. It's actually performing an action. It's operating on some data, right? And what the assignment operator does in pretty much every programming language, right, this is not like a Python specific thing. This is like every programming language you'll probably ever run into, they all have the assignment operator. And what does it do? It takes whatever is on the right hand side of the operator and it assigns it to whatever is on the left hand side of the operator. And what does that mean, to assign it? What it actually means is it copies the value from whatever is on the right hand side, and then it overrides whatever the value associated with the left hand side previously was. So in our case, when I did this, my var had never, it was a symbol that had never been used up to that point in the program, which means that the first thing that had to happen was that the program had to ask the operating system, get space for it, assign an address location, right, in RAM. Then that address location had nothing in it, right? And I don't remember off the top of my head how Python deals with initialization. Probably zeroed out the space, okay? But then right after that, it saw the assignment operator and it was like, oh, I see what's going to go on here. Now that I have this location in RAM, I'm going to go ahead and take this value, copy it. So now I have a 42, just a regular old 42 literal number, right? And I'm going to put that, I'm going to assign that into this location in RAM. And so that's exactly how we ended up with this. At this location, whatever the operating system gave us, this is where that ended up. It seems like I'm beating this horse to death, is that this is one of those concepts that it's easy to just write the line. This was like, a no-brainer line. There's actually a lot of stuff happening under the hood to make that line work. And that appreciating that is very helpful. It'll help you long term as you progress as a programmer. That's why I'm kind of beating it to death here. All right, so that's what the assignment operator does, which is why later on, if I wanted, I could do this. My var now equals 78, okay? I'm just picking random numbers. And if I were to do this now, watch what would happen. The integer is 78. So what happened? The first thing it did is it ran this. It created the variable, right? Basically declared it and then immediately initialized that variable to this value. So for the briefest of moments, the spot in RAM that is associated with my var was set to 42, right? And then the very next line, it was like, oh, we're doing another assignment operation. Okay, Well, I'm going to take whatever's on the right-hand side of this, in this case it's 78, and I'm going to copy that value and I'm going to assign it to whatever this symbol is. Oh, and this symbol now, right now it has 42 in it, but I'm going to just override what previously was there, and now it's going to hold 78. Okay. And then it came down and it hit the print statement, and the print went, okay, let's go ahead and print this, send that out to the CLI, right, to the output buffer, and then it appended this value. Well, then to get the value of the variable at that location, it went out to the RAM and it said, okay, we know what my var is. That's actually address space 256, let's say. I don't know why it keeps highlighting like that. It's this location, and then it went, okay, what value is associated at 256? Oh, that's 78. That's what I'm going to print here, and that's why we got the integer 78. Okay. If I had put a print statement between the two, the integer is, and I'll just make it the exact same thing as I did last time, my var, right? That means that at this point in the program, it would print the value is 42, because at this point it is 42, and I'm printing it out. Then I changed it, and then I printed it again. It is now 78. So my expectation now is when we run it, it's 42, and then it's 78. Okay. So hopefully I'm just showing you how you can kind of marry the concept that we had from last week with this printing, pushing stuff to the CLI, with this new concept of variables. Okay. So variables are, again, temporary location. It's all going into RAM, which means that as soon as the program ends, that information just goes bye-bye. Okay, so all the stuff we're doing is very ephemeral. It's just kind of there for a brief moment, program ends, it's gone. Okay, moving on. Let's talk a little bit more about the rules of naming variables. So variables can actually be named any number of things. Do I want to talk about naming rules? Maybe I should talk about something. You know what? Before I jump into naming rules, let's do one other thing. Let's actually talk about types for a moment. You know, I kind of hinted at this a little bit when I did my diagram, where I said that the program is actually going to request from the operating system an integer. Okay, notice how it didn't how did it know it needed an integer? Okay, well, this is something that's unique to Python. Well, not unique to Python, but the class of language that Python is. Technically speaking, Python is what is known as a loosely typed language. That just means that you don't have to specifically say what kind of information a variable is going to hold. The language will sort of just figure it out on the fly. So in this case, I said, let's put 42 and assign it to this variable. Well, the Python interpreter was smart enough to know, well, 42, this is an integer, right? So I'm going to assign an integer to this. Therefore, my var needs to be big enough to hold an integer, right? It needs to be able to hold that. And if I hover over my var, you might actually see it. Oh, it doesn't do it anymore. VS Code used to actually say the type here. But in the end, it knows this is an integer's worth of space, which means that when it went into RAM, it had to request an integer's amount of space. And different types of information take up different amounts of space in RAM. Okay, this is the information that is, in my opinion, this is one of the crummier parts of Python. The initial kind of implementation of Python was that it's a loosely typed language, which means that it's very easy for you to not know what kind of information is being held in any particular variable. And that can be problematic, and it can actually lead to a lot of problems, which is why most compiled languages that actually use a compiler and not an interpreter, are strongly typed instead of loosely typed, meaning that when you create a variable, you actually have to say this variable holds an integer, or this variable holds a string, or this variable holds a something else. You have to tell it how much space you need to set aside in RAM to hold that information. Python has been around for long enough that even though the language technically is loosely typed, enough people have realized that this is a problem. I mean, it can lead to a lot of problems. So thankfully for us, some very smart people went ahead and implemented a system to help kind of guide what the types should be for each one of them in each one of your variables. And they call this in Python, I believe it's called like type annotations, or also I think it's called type hints. Okay, I'm going to require in this class that you always use type annotations because it will make it better for you in the long run. It'll also make your transition when you leave Python and you want to explore other languages. The likelihood is that you're going to eventually run into a compiled language, and they're pretty much always going to require you to use to declare the type at the time that you're declaring variables. So I just want you to get in the habit of doing that. Okay. So here's how you implement their type annotation in Python. This is what I'm going to be looking for in your submission. So pay attention to this, okay? So in this particular case, I know that I'm putting an integer's worth of data into this variable. So at the time that I'm declaring the variable, instead of just doing this is like the only time you're ever going to see me do it with just the equal sign. Instead, what I'm going to be expecting to see is for you to put a colon after the name of your variable, and then I want you to put the type. In this case, it's an integer. If you do it this way, okay, this is me telling Python, hey, that's the kind of data that's going to be held here is integer data. Now, strictly speaking, Python doesn't require this, and I don't really remember off the top of my head how much enforcement there is in this. I don't really know that there's any. But for our class, I am going to require this. And you're going to see grading rubric requirements where if you don't do this, you're going to lose points, okay? So just keep that in mind. You need to use the type annotations. I'm looking for them. And if you hover over this now, I'm guessing it still says literal my var variable, which is kind of funny. But now you're making it more clear what your intention is as a programmer. I want to make sure that this variable, that everyone knows, this is an integer. This should be holding integer data, right? Now let's talk about the types, okay? So this is where I was kind of leading into where I wanted to go. I think we're going to just stick with types for a minute here. So let's talk about the 4 main data types that you're going to use in this class, or the 4 primitive data types that you're going to use in this class. And I'm going to go ahead and just comment this out. Again, as always, I will give you all of this code, so don't fret on that. All right, let's talk about primitive in Python. Now, this is a little bit specific to Python, but not really, but kind of. So I'll explain. So the first primitive data type that I'm gonna be utilizing in the class is int. Okay, this stands for integer data. Okay, integer data. Hopefully, you might know what that is. It's whole numbers. Okay, so you think of 1, 2, 3, 4, 5, or -5, -4, anything that's just a whole number, non-fractional, that is what we refer to as an integer. Okay, so that is the kind of data that an int represents in Python. And it is a primitive data type. Don't worry, I'll explain what a primitive is in a minute. The next one, float. This stands for floating point data, which you can think of as basically fractional numbers. Okay, so let's say you need to hold 3.2 or 1.56 or something like that. Okay, if you need to hold that kind of numeric data, then you're talking about a float or a floating point data. So that's the other primitive data type that we will use in the class. The other one, bool. This is for Boolean data. I'm not sure what that means. It's basically true false. Okay, so bool stands for Boolean, okay, and Boolean data basically just means true or false. It only holds one of 2 values, true, false, yes, no, 1, 0, okay, it's Boolean. And the last primitive data type that we will do in the class is string data, okay, and this is a primitive data type, and this is basically, you can think of this as a series of characters. Okay, so earlier when I was talking about string literals, like in the last lecture, if I didn't want to just print a string literal directly to the terminal, I could also store a string literal as a string data type, right? And it would hold that information in RAM, and then I could do whatever I want with it later. And I'll showcase that here in a little bit. Okay. These are the 4 primitive data types that we will use in the class. There are more than these in Python, but these are the 4 that I'm going to use throughout the semester. These are also the 4 that you're pretty much going to find in almost any programming language that you're ever going to use. Maybe some small caveats for like C or C++, which don't technically have strings as primitive data types, but they have ways to get to the string just a little bit differently. But most programming languages are going to have all of these. In fact, I can't think of a language that doesn't have integers, floats, and booleans as primitive data types in every single language. They're that foundational, which is why I want you to know about them. And I'm not overly interested in whatever other wacky ones that Python has. Not a Python class, right? I just want you to know the core. All right, so these are the primitive data types. Now, what do I mean by primitive? What I mean by that is you don't have to do anything special to the Python interpreter for it to know how much space to set aside in RAM for each one of these types. Okay? It knows how to handle each one of these types. It knows that when I came up here and I did this, right? It knew exactly what to ask the operating system for. It was like, "Oh, you're looking for an integer's worth of space?" The Python interpreter was like, I know how much space that is, right? I'm just going to make sure when I request this from the operating system, I tell it how much space. Because from the operating system's perspective, it doesn't care the name of your variable. It doesn't care one bit. It cares about address spaces. And it just needs to know, okay, well, if I start you here at 256, right, and you need X number of bytes, right? Are you going to run into another address space that already has a value in it from some other program? And if that happens, then I can't use that address location for you. That's why it's so important for it to know how much space you actually need for your variables. Okay, that's why it's important. So uh, when that's also, like I'm saying earlier, like that's also why it's important for you as a programmer to understand this relationship a little bit. And that's why even though Python hides it from you, under the hood, it still has to know how much space it is because that's how it's talking to RAM. Okay, I'm going to comment that back out. And I'm just going to make a little example using each one of these just to help kind of highlight this. So let's go with my int, and we'll say my int. And again, I want you to use the type annotations equals, again, we'll just go with 42. That's an example. Okay, we'll do another one right here. We'll say my float. And we'll say float equals, I don't know, 3.14. That's like pi, right? Delicious pie. And we'll say my bool. You're going to have to deal with a lot of my bool this semester. We'll go with my true. Okay, and again, booleans are either true or false, so I'm just assigning this initially to true. And then the last one I'll do here is my string. I'll say my string. I'll actually type all the way out, and I'll say it's a type string. And we'll say it's equal to Mary had a little lamb. Look at that. Okay. There's all of the data types, and I'll space them out a little bit here just to make it a little easier. Again, I'll give you this code, so I don't want you to stress out on it. And then here, and just to make this even easier, let's go ahead and print each one of these out. So this one will be my int. Or here, actually, just to showcase that you can do this a number of different ways. And actually, it occurred to me the other day that after the first lecture, there was one part of print that I didn't show you, so maybe I can use this as an opportunity to showcase it now. So I'm going to print them all out now, and I'm going to say my int first, and let's say I wanted to put it on a new line. I wanted to, let's say between every single argument, I wanted to put a new line. Remember I showed you that neat one called sep, right, where you could create the separator. So let's say I just wanted to make a new line between every single argument. Well, now I've done that, I can say my float, my bool, and my string. Okay, and by doing it this way, what I basically have said is instead of putting a space between each one of them, put them all in a new line, because I basically created the separator and put it as a new line. This is something I showed you last time, but I'm going to show you one more thing. Python variables. All right, and now see how they're all in a separate line. So there's all of the information. Here's another thing you can do. Let's say I didn't want the whole thing to end with a new line. So you remember how I told you that print by default pushes a new line character at the very end of your statement. So for example, if I were to say another print here and say like another line or another print statement. Okay, there's that. And I'll run it again. Okay, so notice how it's just putting another print statement at the bottom even though I didn't do anything like that. If you ever want to not have that happen, if you don't want it to append a new line, you want it to change or specify what it does at the very end, you can actually do one more override here called end. I meant to say this last time. And let's say I just wanted to have it do nothing. right? So basically what I just told it is, yeah, don't put a new line at the end. Put nothing at the end. Okay? Well, now if I run it, Mary had a little lamb, another print statement. So I basically just told it, don't put that new line. And now if I want, that also means I can do other things, like maybe I want to have two new lines at the end. Okay? So now, instead of just having the one new line at the end of it, I'll put a little space between it. Now there's two of them. Right? Just another little bonus thing you can do in Python. Not super important. You certainly didn't need it for the last week's assignment, but one of those little nice things. Toss it in there for you to know about. Okay, but the most important thing here, these are the primitive data types. These are the types. Okay, that's how much information they can store, and this is how the relationship. I've sort of explained that relationship with your variables and RAM. Okay, that was the first main concept. Um, the other thing I want you to know about with variables is the naming rules. You could go look this up, but I'm going to quickly tell you what they are. You can pretty much name your variables whatever you want. There are only a few naming rules. First and foremost, you can't start your variables with a number. They have to start with something, either a letter of some sort or underscore. Underscore is the only exception to that. So I can't start this off as 7 my int. Immediately you can see that VS Code is saying no dice, and you should never just 100% trust VS Code. So you should probably just run it through the compiler or through the interpreter, and immediately it's saying, hey, invalid syntax, it doesn't know what this is. You can't start variables with numbers. Okay, you can't start it with something other than characters. So I also couldn't start it with like open parenthesis or something like that, right? Only letters and underscore. They're case sensitive. So just so you know, variables, I mean, they're case sensitive. So if I come in down here and I say my int equals 87, that is a completely different variable from this one. They have nothing to do with each other. As far as the interpreter is concerned, this means a different spot in RAM than this does. Okay? So just so you know, it's very easy to get mixed up if you start naming variables extremely similar things and the only thing that's different between them is like a capital letter. It can get you in trouble. So just keep in mind, it is case sensitive. And that's true, again, all programming language. That's not a Python thing. Most of these variable naming conventions are true in every language. I can't think of any off the top of my head that's not the case. It cannot start with a number. I'm just looking if there's anything else in here. Yeah, that's it. That's pretty much it. You can add numbers and other characters afterwards. So like if I want to say my int 1, that's perfectly fine. You just can't start the variable that way. Okay, so just FYI, it's that number situation is only the very start, has to start. And then if you want, you can also of course use underscores. Those are the only other character you can use in here. For naming conventions, some people like to do this thing that I'm doing, which I think is referred to as like a camel case, where you start it off with lowercase, and then if you want to denote like another word in the variable, you would just uppercase the first letter of that word. Some people might do other conventions like this. I can't remember what it's called. There's lots of conventions. Some companies you might work for might actually dictate to you the variable naming convention, and they might even have like a linter that they run on your code that actually just does it for you. So it's not something I get too. I don't personally care what you name your variables. You can name whatever you want, but just to recognize that the interpreter itself does have some naming rules that it will enforce on you. Okay, I think I've finally beaten variables to death. Let's move on. Let's move on to the next operator. So last time I talked to you guys about how to push information to the CLI. Now I'm going to show you how you can retrieve information from the CLI and bring it into your program, okay? You might have been asking yourself, like, why didn't you just start with that? Why did you go on this little side quest with variables and RAM and all that stuff? Well, a quick question to ask yourself might be, if you're collecting information from the user, right, that means there's data that's leaving the user side, or here on the CLI side, they're going to type something in here, right? And you want to bring it in, where's it going to go? Has to go somewhere in your program, right? It's for you to be able to use it. Well, where did I just talk about for the last, like, I don't know, half hour, 45 minutes? That's what RAM is. RAM is the place that your program uses to be able to store information while the program is running. So you are going to need to create a variable to collect information from the user. That's why I started with that. There is a method to my madness, I promise. All right, so let's talk about how to do that. I'm going to create a new file here to do it. Let's say I'm going to call it input. Yeah, I can't think of a better. Actually, I'm not going to call it input. That might actually cause a problem with Python. Let's say standard in or something like that. I don't know. I can't. Yeah, I can't think of a better way to put that. Take the type annotations in your code. Recommends enabling type checking. Would you like to change this setting? I don't know. I mean, do you want to use PyLance? You can. I'm gonna be honest with you. VS Code and the IntelliSense systems are nice. While you're starting to learn, I think I take a very minimalistic approach. I'm gonna say no, actually. I'm gonna take a minimalistic approach to this because I don't really want anything that might monkey around with the code I'm writing. I just don't want to deal with it. I want you guys to see how it is to write code and understand what the code is doing. Okay, so again, let's just go ahead and get our proper code layout in there. Um, let's talk about how to collect user input. So remember last time, I just did it a few times, print is your go-to function for pushing information out to the terminal. There is a go-to function for collecting information from the terminal, and that is input. Okay. So input is a special function that Python just gives you for free out of the box. And basically the way it's set up is you type input, and then between the opening and closing parentheses that follow input function, again, it's sort of an argument that you're passing it, just like I talked about with print. The argument that you put in immediately is a string literal. You could also just put a string data type in there. In fact, maybe I'll demo that in a minute. But typically you would just put a string literal in there like I've shown, and then you basically put the prompt that you want to put in front of the user that's going to let them know what to type. So input is by design, is the idea is that you're going to ask the user for something, and then the program is going to wait for the user to type that into the CLI, and then they're going to hit enter. And upon them hitting enter, it's going to grab anything that they put into the CLI, bring it into your program, and it's going to, do something with it. And I'm going to show you how you can do something with it here in a second. Let's just start real simple, input with a prompt. So I'm going to say, please enter your name. Okay? And I'm going to hit save right now, and just so you can get really clear, really comfortable with how this is going to work. So I'm going to say Python stand in, and please enter your name. And notice how the program is just sitting here now, just waiting. The program hasn't ended. Notice how I don't have this prompt afterwards. My program is still running right now. Everything is still in RAM, right? There's nothing has exited yet. That's because it has prompted me and it's now waiting for a response. So I'm going to say my name is Matt. All right, so the first thing you might have noticed is, look at that. That doesn't look like very good. That made me type it like right at the end of name, right? So you're probably always going to want to put a little space at the end of this, right? Sometimes people like to put a colon at the end of this to make it kind of look a little nicer, right? But after I hit Matt, I hit enter, and boom, program ended. I'm back to Python now. Or I'm back to PowerShell now. Okay. I'm going to go ahead and save the changes I just made, run it again. That looks a little better. Matt, enter. Okay, so there it was. So now you might be asking yourself, like, where did that Matt go? Where did Matt go? Who is Matt, right? I'm right here. I'm standing here. I'm talking to you. Sitting here. The recordings get more ridiculous as the longer they get. So please enter your name. So let's say I want to collect the information that comes back from this function. So they entered something and I want to actually collect it and put it into a variable. Well, let's go back over to our friend variables. What do I do when I want to declare a variable? What do I use? I use the assignment operator. This is just a beautiful excuse for me to restate what the assignment operator does. Let's talk about it again. It takes whatever is on the right-hand side of it, copies the value, and assigns it to whatever's on the left-hand side of it. Okay? Another way to sort of demonstrate that that's exactly what it's doing is that try to do something nonsensical like this. Let me just reverse this now. 42 equals my int. I'm surprised if it'll even let me do that. Python, what is this, variables? Yeah, doesn't like it. Look, and here's another great opportunity to showcase VS Code is not the keeper of truth. It did not put any kind of red squiggle here for me. Probably should have. This is clearly not a valid use of the assignment operator, no red squiggle, but the interpreter, the real keeper of the knowledge, it told me right away, hey, on line 21, you can't assign to a literal. I can't copy whatever is inside of this variable and assign it to 42. 42 is always 42. That's just a number. It's a literal number. I can't put information into 42, right? This is a nonsense statement. So hopefully that helps reemphasize what the assignment operator does. Always takes whatever's on the right and puts on whatever's in the left. Okay? Here, I'll even leave this here. You know, I'll put doesn't work. All right. Okay. So if I want to collect the information that input just got from me, what am I going to use? Well, I'm going to use my good friend, the assignment operator. And what am I going to do? I'm going to create a variable to hold the information. Now, here's a little piece of information that you should know about the input function. It always gives you back a string, right? So one of the data types that it always returns to you is a string data type, which is just a series of characters, which kind of makes sense because there's no way for you to know what kind of nonsense your user was going to type in here. They could type anything they want. They could just mash the keyboard with a bunch of keys, right? So without knowing specifically what they're going to type, string makes the most sense, right? So it's always going to return a string of data. So I'm going to now create, let me say like my name, or let's go with username. Username, let's say that. Again, I'm going to use my type annotation to tell Python, hey, I'm expecting a string here, and then I'm going to use the old assignment operator. Okay, assignment operator is going to take whatever's on the right hand side. So it's going to run this function first, collect the information from the user. Once they've entered that information, they've hit enter, all that information is going to come back. It's going to take whatever that value is and it is going to assign it to this variable. Okay, and now I'm going to have that variable stored on in RAM so that I have access to it. And let's say I wanted to print it, I could say print your name is username. And we'll do that. And we'll run it. I don't want that one. I want stand in. Please enter your name. Matt. Your name is Matt. Okay. Easy peasy lemon squeezy, right? So that's what the input function does. That is how it collects information. And now you also know that it always comes back with a string. Now, this is going to lead us into a little bit of an advanced topic that I can't really get around, to be honest with you, because we're using Python. So we're going to have to talk a little bit about data type conversions. Okay, or more specifically, more commonly, what we call it is casting. So when you cast something in programming terms, what you're really saying is, I'm going to take some data that is actually stored as a certain data type, right? In this case, this is the data type, a string, right? And I'm going to convert it from that type to a different type. Okay. Now I have to do this because we're using the input function, which is a delivered function that like everyone who's starting out in Python when they're learning how to program, that they pretty much all use it. Okay. But because it always returns a string, that means I'm always dealing with string data. Sometimes I might want a different data type. Maybe I'll ask the user something that's not just their name. Let's say I wanted to know their age, or I wanted to know their favorite number, right? Let's just go with number, that's easier. So let's say fav number, fav integer, let's say. All right, fav integer is an integer, right? Equals input, please enter your favorite integer. Okay, now let's say they did that. Now I think we're going to probably run into a problem right away. Print fav integer. Okay, because this is always going to return a string, isn't it? So let's do stand in. I'm still Matt, and my favorite number is 42. Of course, it's always the correct answer. Right, your favorite number is 42. Okay, so right here, I'm going to let you know, and this is actually a good thing for you to know. Despite the fact that this always returns a string, in fact, you can tell that if you look at the little IntelliSense, see how it says this little arrow pointing back out. This is letting you know it's returning a string. It's always returning a string. Okay. Despite that, right, and despite the fact that I told it, hey, I'm expecting an integer here, there's nothing enforcing that. Okay, so this doesn't enforce anything, these type annotations. This is more just for you as the programmer. And the reason I'm forcing you to do it is because I want you to build good habits. I want you to be deliberate about knowing what your variables should be holding, because it's a very useful skill for you to have. It's a good thing to do as a programmer. But there's nothing in the Python interpreter that necessarily enforces that. Okay, so even though I told it was supposed to be an integer, it didn't. It held a string. Okay, so this might not seem like a big deal because it's like, well, hey, it's still printed it out just fine. That is exactly what I wanted, right? That's fine. Okay. Now let's say I wanted to raise that to the second power, or actually maybe even easier than that. Let's say I want to divide the number that they gave me by 2. Let's say I want to divide it by 2. So how might I do that? This lets us go into a whole other thing. Operators, math operators. There's a bunch of them. I'm going to let you guys look up most of them. But let's say for this one, the easiest way to do that would be to say divided by 2. Okay. 42, we already know that's what I'm going to type in, right? 42 divided by 2 is clearly 21. Okay. Let's see what happens when I run this now. Matt, 42. Oh no! I got an error. Okay. And the reason I got an error is because this is a string. This even though I told it it should be holding an integer, and if you were to divide an integer by 2, it's fine. Okay? But what actually got stored here was a string. And strings, how would you divide a string by 2? Like how would you do it? Like because there's nothing stopping me as the user from coming in here and typing what is your name, Matt? My favorite number is, hello world. Okay, there's nothing stopping me from doing that. How would you divide hello world by 2? Right? It's not really an integer. Okay, so a lot of different ways you can handle this, and this actually leads us all into a whole other thing about validation, like input validation. I'm not going to do that. In fact, this is a good thing for you to just know about this class. Unless I explicitly put it into my instructions for an assignment, you can assume that I will never run one of your programs with invalid input. Okay, so let me say that again. Unless I explicitly say that in my instructions that you need to account for different kinds of input validation, unless I explicitly say that and I've already told you how I want you to do it, you can assume that I will never run any of your programs where you collect information from the user and then I put in some nonsense input. I'm never going to do that. It's never going to happen. That's a fairly advanced topic, to be perfectly honest, beyond the scope of this class. I could have a whole other class just on input validation. I'm not doing that. Okay? I will never do that to any of your programs. Okay? That said, if they actually do the right thing here and type in an integer and not hello world or some other nonsense, okay? Let's say we can just assume that they typed in the correct thing, in which case the problem here is that I just need to be able to take it to something that is a string that's holding a number in it, right? That's actually just it's as if somebody typed in like this, 42, right? See how it's between the two quotes? I needed to make it go from that to just real 42. Like that's what I'm trying to do. I'm trying to get it to go from a string that holds the number 4 and 2 next to each other, right, and turn it into an actual number 42. Those are stored differently in RAM because they're actually this I can do math operations on. This is just some characters put together. Could be anything. Okay. So the way you do that is by casting. And the way that we're going to do it in this class is if you're in a situation where I'm wanting you to collect, let's say, integer information, it's pretty easy. You just type the word int, you open parentheses, you go to the very end of this whole thing, and you close, right? And what I'm basically saying is this is now anything that this had, this string, this whole big thing that was a string, I want you to cast it, assume that it's an integer, and turn it into an integer, and then copy that whole thing, and put it over here. Okay. When I do that, when I come in here and I run it, say my name is Matt, and now let's say I really do put in a number. I follow the directions, not invalid input. Get 21. Right, works just fine because it was able to actually convert it over into a real number. Okay. So this is what we're going to do. This is how you would cast something to a different data type. And the most common way you're going to see us do this in the class is going to be for the input function. So get really cozy with this setup right here. This setup right here is totally a very typical way that you could do it. Um, you don't necessarily have to do it this way, but it's nonsense to do it any other way. In fact, if you were to do it, the only other way you could probably have done this, I suppose, is you could have done something like this, and then maybe had something like, I don't know, temp, and then you treat it as a string, and then you would have said, oh, okay, now actually fav integer, which is an integer, is going to equal int temp. Okay, that also would have worked. Now this is kind of silly. This is why I say this is a silly way to do it, because what I basically did is to avoid having to do the cast here, I collected it, put it into a temporary variable that is of type string, and then I cast the string into an integer and put it here, and then I went ahead and did it. And this should work just fine too, as long as I keep doing the same input. Let's do mat, and we'll do 42. And we're back to 21 again. Okay, so this is another way you can do it. I'm going to say right now, if you do this, I mean, I'm probably not going to knock off points, but like it's going to be weird, and you're probably going to see a little comment from me. Don't do this. The way I'm really expecting everyone to do this in the class is like this. Okay, so you're just pretty much you just get in the habit of doing this, and we will eventually get to a point where I show us some other ways to collect user input, but this is going to be our go-to method for quite a while. So just kind of get cozy with that. Okay, so that is the standard in. That's how you basically collect input. I don't really love this name. I'm going to change it. Actually, I'm going to call it collect input. Let's go with that. Maybe that's a little better. Collect input. Okay, there you go. Last thing I'm going to quickly talk about is a couple of additional things you can do for printing. So actually, I'm going to go through fancy print variables. There we go, that py. Okay, so we'll do one more file, and in this one, the point of what I'm going to do, I'm actually going to just copy. Let's go with this fav and this. See, and we'll come in here. Okay, so in this file, again, I'm going to ask the user for their favorite integer. I'm going to immediately cast it, and I'm going to create a fav integer. Now, this is one way that you could have printed out the integer. Another way you could do is maybe say like, please enter your, enter the cost of the jacket. Let's go with that, the cost of the jacket. Okay. Now this is still going to come in, like let's say cost. It's still going to come in as a string, okay? But I'm going to cast it, so it's actually going to come in as an integer. I just realized I probably should fix that over here. Yeah, this is supposed to be an int now. There we go. Good. I don't want to give you bogus code. Okay. See how you're already getting thing. It doesn't know what fav integer is anymore because I changed it. Okay. So what I'm going to do now is I'm going to say the jacket cost. And now what I'm going to do is I'm going to change this to a $sign, and then I'm going to say cost. Okay. Now, a couple different ways you could deal with this, and I think I might have showed this last time. I can't remember. Print variables. Let's say the 42. It's always 42. So just know that about me. It's always the same. Now remember, we're gonna have this problem, right, where it puts the $sign not right next to where you want it to be, and so you might think like, okay, well I can get around that by doing this separator thing, right, and I'll just make it nothing. Okay. And that's fine. That might work, but this actually is a pretty limited way to make that work. Let's go 42. It's a limited way of making that work only because let's say you have a lot of stuff that you want to print, and sometimes you do want the comma, the different arguments to actually have a space between them, and only like one time you didn't want to do that. Well, this is sort of a global thing you're doing for this entire print statement, right? So it's not the most elegant way. So I'm going to show you a couple other ways that you can actually print information that's stored in variables using the print statement. A couple of sort of nice ways to sort of format the output. I'm not going to use separate in this case. In this case, what I'm actually going to do is first I'm going to show you sort of the old school way. It's still a perfectly valid way. It's a good way, but it's a little bit old school. And that is to use a special function that's a part of all strings. And that is what you can do. It's called I think it's called the format function. So the way you do it is this: you do a open and close curly brace. Again, now notice how I'm actually inside the double quotes. Okay, I'm actually inside the string literal. And then I'm going to close it here. Then I'm going to do dot. And then I'm going to do format. And then I'm going to do this. Now, that might seem like a lot. So what I'm going to first thing I'm actually going to do is I'm going to come in here and I'm going to say formatted cost or formatted output. Let's go with that. This might make it a little easier. And I'm going to say this is a string. And I'm going to set it equal to this whole thing, just so you guys can get a sense of what this is actually doing. Okay, so when you have a string literal like this, if you do this little thing where you have an open and close curly brace inside the string literal, and then you do a dot immediately following the string literal, and you can do dot format, whatever variable or value you put in here will get replaced with whatever shows up here in the string. Okay, so just to showcase what's going on here, formatted output. So now I'm just going to print out the formatted output. So I created a variable called formatted output, and I set it equal using the assignment operator. It copies all of this. It uses this special format function to actually to swap out whatever value cost is and put it right here in the string. That's all it's doing. Right, and then I'm going to print it out just so you can see what it's doing. So let's do print variables. Again, I'm going to go 55 this time. The jacket costs 55, okay? Because that's what this ends up becoming. And the nice thing about format is that you can just keep doing it. So I can actually go, the jacket costs this, and the other thing cost, and let's see, I'll put another dollar sign here, and I can put another curly brace, and then I can just keep adding more stuff in here. And in fact, this time I'm going to say 100. I'm actually just going to put a number here. And notice how I'm not putting a string literal. I'm not putting like a string here. I'm actually putting an actual value, a number. It's going to replace this value and put it here, and it does it in the same order that I did everything in. So the way that format is set up is that the very first time it reads from left to right, the very first time it hits one of these open and close curly brace, it will replace that with whatever the first thing was in format. Then it's going to keep scanning, and it gets to another open and close curly brace. It'll use the second thing in the format and replace it there. Okay, and it'll just keep going. You can keep doing that over and over and over again for as many things as you want. They just have that, so that just means however many open and close curly braces you have in the string, you need to have that many arguments being passed to format. Otherwise, it won't match up and it won't know what to do. So let's go here. Let's go with this, and we'll say the jacket costs, I don't know, 3. So the jacket cost 3. The other thing cost 100. It used the 100 that I put here and replaced it there. Okay. So this is a little bit of an old school way to do it. Now I'm going to show you, you don't necessarily have to create this temp variable to do this, right? You can actually just take this entire thing, cut that, put it in here, and now it's just doing all of that instead of me creating a variable to do it. It's just doing all of that inside of print. Okay, so that's all I did. So I just did that whole thing inside of print. And again, I will go here, run it. This time I'll do 77. The jacket cost 77. The other thing cost 100. Okay, exactly the same thing. I just did it inside of print. Not like one way is better than the other. I'll put this back the way it was, just so you can see a couple different ways to do it. So there was this. In fact, I'll copy that. And then we'll go back to, let's see here, boop, boop, boop. Oh, not that. That's a little too much. There we go. We'll go here, and now we'll say the jacket cost, copy. I'm going to comment all this out, and then we'll show you the other spiffier way you could do this. We'll go here. Oops, let me do that. Oh boy, press the wrong button. My bad. Okay, there we go. Does the same thing. Okay, slightly different ways you could do the same thing. You know. And I'm going to do some commenting, because if you want to look at this code later, I want you to have some sense of it. So I'm going to say it demo. And this one will say demo 2. Right, and we'll comment that out as well. Okay, now I'm going to show you another way you can do this, and honestly, this is probably the way that most people are going to want to do it. But I wanted to show you sort of the old school way, because it's possible that you might also be using, sometimes you might get in environments where you're using an older version of Python, and this other way, maybe it's such an old version that you genuinely, this function doesn't exist anymore, and so you might need to use the format way. So I just wanted you to know about it. This is kind of a Python specific stuff I'm showing you today. Like this stuff is very Python, but you're gonna be doing a lot of output to the CLI, so it's kind of like, okay, know how to do it, responsibly, or proficiently, I guess. So let's do it. This time I'm going to use what is called an F string. An F string is a special notation that came out in a later version of Python that makes it a little easier to do exactly what we're doing here. So here's what I'm going to do now. I'm going to take this exact line I did right here. Okay. Same exact thing, but this time instead of doing this kind of a little bit wacky way of doing it, you can actually do it a little easier by just doing this. Cost and 100. And you don't even have to do this anymore. Okay, this is what is known as an F string. Okay, and actually let me just look at something. Oh yeah, the one thing you do have to do if you want to use an F string is you have to put an F in front of it. That's how it knows that it's an F string. It's just a special string function. So if you put the F directly in front of the string literal, then it knows to treat each one of these open and closed curly braces as like a placeholder, and then it'll placeholder all of that stuff, and then I can come down here and do print formatted output, save, and then we'll watch it happen. And remember, I have everything else commented out, so the only thing that's going to happen now is it's just going to collect the input and then run it. We'll do 4, 5, sure. The jacket costs 45, and the other thing costs 100. Okay. Still works exactly the same way. And just like how I did in the other one, I guess I'll just go full on parity and demo. Demo 4. Or not print function. I'm going to take this whole thing, cut it from there. I don't even need this variable. Just put the whole thing in there. This is probably what you're going to see the most of the time, and going forward you might just see me do this a lot when I'm writing code because it's a simple thing. It's just kind of the cleanest way to do it. I don't know, 88. Oh, I left this in here. I didn't comment it out. Whoops. All right. Well, actually, it showed the same thing. Like, see how it said the same thing no matter which way I did it? It was exactly the same thing no matter what. So just get rid of that, and we'll go with, I don't know, 89. And the jacket is 89. The other thing is 100. There you go. Okay, so here's the other way you can do it. And I'll give you this code. So I just want to show you those two different ways that you can also print stuff. I didn't show this last time because we hadn't gotten into variables yet, but this is stuff that you would normally do, like using an F string or using the format function is something you would normally do when you're wanting to take the value of a variable. Again, the value, go full circle here, the value stored for one of my particular variables, and I wanted to basically put it inside of a string so that it would actually take the value, maybe it's an integer or a float or a boolean or something else, and actually put it into the value of the string. It does that swap automatically for you. You can use one of those methodologies to do it. Most commonly, you're going to see me do this when I'm printing stuff to the CLI. Okay, so let me just quickly check my notes to make sure I got everything you needed. I think we're good here, so let's just go back over to the course module. So for this week, this is what I have for you for this week. You have 2 assignments besides just the Piazza post. You also will probably have a quiz in here. I'm not really sure why it's not displaying. I think you have a quiz. I think you have either the CLI quiz or the, I don't remember. You'll find out if I activate it in a minute. Helpful resources. I don't know if I touched on this last time. I always put supplementary information for the stuff that I go over. So here's some articles related to primitive data types and retrieving information using the input function. Every week you'll see me put some stuff into helpful resources. So it's meant to sort of supplement these lectures. Uh, the two assignments that you have that are programming related this week are input number, output number. Okay. The main point of this assignment is for you to demonstrate to me that you understand how to use the input function. I think I kind of did a big chunk of this right now with my example code, so hopefully that just sort of gets you a good chunk of the way there. But the idea is that you're basically going to write a little script that collects some information from the user and then prints out that number that they entered plus then basically double it, so double the value as well. Okay, I think I did something very similar to that, so this should be pretty much a breeze for all of you. Remember to follow these. Oh, it looks like when I did this in my example student didn't do. See, don't be like the example student. Don't be like my pretend student here who gets no marks. This is what you'll see when I grade stuff. So maybe it's a good example. When I grade things later on, if you don't do some of the work, like let's say you didn't do the proper code layout at all, you can expect to see that there. If you did everything else great, you should see this. Okay, but just to highlight for this particular assignment what I'm looking for, it is 15 points for the proper code layout, making sure that you collect the user input. Okay, and you can always look at the view the long description. The submitted code collects the user input via the input function. So I'm specifically telling you, you need to collect it that way. If you somehow figure out a different way to do it, I wouldn't expect to get any points because I'm telling you how you're going to get the points here. Convert the input. The submitted code converts everything into the correct value, and then I'm even like specifically telling you, you better use type annotations. All right, so this is a part of the requirement. If you don't type annotate it, you probably will lose a few points. Don't be that person. And then correct output is just exactly what it sounds like. It produces the exact output that I am outlining right here. So the reason I usually give you multiple example outputs is so that you have something to test against. So if I were done writing this program, and probably all future programs, then I would immediately run my program. And if my output looks exactly like this, and then I push it, the input is in bold and underlined just to help anybody who might have misunderstood what that meant. This does not mean that I'm expecting your program to somehow bold or underline input. No, I'm just showing you a way to distinguish, like in my little example here, this is input, this is output. I'm distinguishing the input and the output by making some of it bold and underlined. That it's meant to help you read this example easier. That's all it's for. Okay. So here's one where I entered 42 as the example input. Here's one where I entered 123. Here's one where I entered negative 25. Okay, so I would run through your program with those three different inputs just to make sure the output looks exactly the way it's supposed to. That's a good, easy way to know if you did the assignment right. And then let's go ahead and scroll back. Take a drink. And then Bad Code Brad. Okay, so this is your first Bad Code Brad assignment. This is a series of assignments that I give. And my good buddy Brad, he's just a really swell young man who, for the life of him, he just cannot write syntactically correct code. He needs your help. He needs you to help him be the programmer he could be. This is a series. You're going to see a number of these throughout the semester. Basically, what you're going to get is some code given to you by a fictional character fictitious character that I've created named Brad. And Brad is going to give you some bad code, right? Some code that he was trying to do something, but it doesn't work. It's all there's just so many syntax errors, so many problems. I give these assignments because I want you to get a feel for what it's like to review code that you did not write, that you were not the person who wrote the code initially. That is what most of software development is. It is not you sitting down and writing something from scratch. If you become a professional and you're working in a software development area, 99% of the time, you're looking at code that somebody else wrote and you're reviewing it and you're modifying it or checking it for bugs or doing something to it. You are not the originator of the code. And school traditionally does not do a great job of sort of getting folks prepared for that. So this is my little attempt at trying to kind of remedy that. So you're going to see some code that you did not write. Your job is to go through that code, find all of the problems, fix those problems, and then comment the problems, right? So comment whatever it is that you find that was not correct about it. Part of your assessment for this assignment will be me seeing some legitimate comments telling me what you changed and why you did it. Um, as a To help you with this, don't just click on this. This is a Canvas bit of Canvas advice. Don't just click on this to get the code. Click the little down arrow. The down arrow is how you actually download it onto your computer, right? And then you can actually modify it on your local computer. If you click on this, it's going to try to open it up in like the Canvas viewer, and it's a Python. It doesn't know how to do it. It's going to look like garbage. Don't do that. Click the down arrow. Let's see here. So, and again, you got some example output. This is telling you pretty much exactly what it's supposed to look like. So I try my best to tell you exactly what I'm expecting. Please do not go and make your example output look something similar to this, but like you choose different words or different stuff. You'll lose points on the evaluation. I'm looking for it to look like this. This is what I want it to look like. I don't want it to look kind of like this. I want it to look exactly like this. So do that, okay? It's an easy way to lose points is to go off and to do your own little side quest on what you think the output should look like. All right? So I'm giving you examples so you can show me you know how to do it. Let's see here. And then, yes, of course, here's the grading rubric as always. If it runs without any errors, which means you've got rid of all of the syntax problems and you get half the points. If it has correct output, meaning that when I run it and it does exactly the things it's supposed to do, that's great too. And then, of course, I am looking for comments. So comment the code. Let me know that you know, like you made the correction, and then tell me what you did and why. Okay, that's what I want to know. That's the other assignment. You'll submit it in Canvas. And I think the last thing we have on the list here is Piazza posts. So I haven't had a chance to review the Piazza posts up to this point in the semester yet, as of the time I'm making this recording. But my hope is that people are in there, they're asking questions, getting their questions answered by others in the class or myself. And I really want to make sure that that community continues to get grown because it's a really useful tool. All right, well, I think that's everything I had on my list for today. This was a little bit longer of a lecture. This is kind of what you should expect going forward. The first or the second lecture ended up being a lot shorter than I expected. So hopefully you're taking my advice and watching them at double speed so you can get through them a little faster. All right, well, thanks for watching, and I'll see you guys in the next one. Adios.